Hello and welcome to this instructional video on CATIA prismatic machining. We've been doing a sequence of videos in which we've been looking at how to machine the part in front of you. If you've been following that sequence, please go ahead and open that part. If you recall, we've gone through the steps of creating setups, adding manufacturing programs, and we've added two operations up until this point. One is a curve follow operation, which is used for engraving. I'm going to right click here and replay toolpath so we can see exactly what that did. So we can see the toolpaths for that engraving. We have the replay window here, which we can use to drive the tool through that engraving pattern. And if you recall, we used a curve follow operation for doing this. So that was one operation we did. Okay here. And the other operation, which was actually an operation that needed to be done before the etching or engraving, is a facing operation. So again, right-clicking, facing operation, replay toolpath. You can see the toolpaths that were generated for machining this face. Now this part has two setups, as we've also discussed. So we're working on the first setup, and to complete the first setup, there are a couple more operations that we need to get done. If you look closely, if you zoom in, you will see that the stock is oversized, of course. We've left machining allowance both on the top, which we took care of with the facing operation, but there's also machining. Let me go to the front view. There we go. So I'm using the front view, and I'm going to zoom in. You can also see, of course, that there's some machining allowance on the side, and that material has to be removed too in this setup. And then there's a chamfer here, and we also have to put that on before we remove the part and flip it over for the second setup. So that's what we're going to do in this video and the next one. In this video, we're going to focus first on removing the machining allowance on the side, and we're going to use a profiling operation, which is a new operation, to do that. So let's go ahead and start doing that. So the procedure is very much similar. The steps that one follows is the same as what you've seen previously. Of course, we're going to be working with a different operation. So again, I'm going to decouple or undock the operations toolbar just so that we can see a little bit more clearly what we're selecting. And we're going to go over here to the profile contouring operation, and we're going to use this operation to define the profile to remove the material on the side. So let's click on that operation. And one thing that may or may not have happened, depending on what you had selected in the tree, is the profiling operation gets inserted into the tree. I had the facing operation selected, and that's why it inserted it after this. So just to backtrack, I'm going to cancel this just so that we can all be on the same page here. If I want to insert the operation in the tree, I have to highlight the operation that I want to insert it after. So in this case, the facing operation highlighted, and then clicking on the operation, and there's the profiling operation inserted. Here's the definition window for a profile. As before, there is this, we start off on the second tab, and that's the definition of the geometry, and then we move to the right and then double back to the first tab. And as before too, the picture that's displayed is a picture that has pickable elements on it. Pretty much everything that's red or pink colored are entities that you need to select. There are also things too that one can set by picking on the text, and that pops up text fields that one can edit. So let's look at this image here and see what we need to specify. So the first thing one needs to specify is the top of the profile. That is where the cutter first hits material. That's what I'm highlighting here. One also needs to specify the profile itself, which is really a set of curves, a loop of curves that one picks, or a loop of faces. And then the bottom of the profile. And then depending on whether or not you have an open or closed profile, you may need to pick limits. So limit 1, limit 2. Now in this case, the profile is all the way around the part, so we don't want to pick limits in this particular case. But there are many cases where you're only profiling along a particular wall. You're not doing a full circuit, so you have to pick limits in that case. Here's the bottom of the profile, so that's how deep you're going with the cutter. Now if you go down to this text here, you notice that the bottom says a hard bottom. If you click on this, it removes the bottom and it says a soft bottom. So when you're profiling, you don't necessarily have to generate a bottom surface. You could just be profiling and just working on a wall. And that in that case, you would toggle this to a soft bottom. In this case, there's a plane because one still needs to define how deep the cutter goes. It's just that it's not really generating a final surface, bottom surface on the part. If we look at what we're trying to do here, I'm going to go back to the front view. We're going to want to machine down to somewhere past this because we're going to remove all its material down here in the second setup. So we're really not generating a final surface of the part, so it would be appropriate in this case to use a soft bottom and to just select a plane past which the cutter is going to go in depth in order to make sure we go deep enough to remove all the material that we need to remove. So actually this would be appropriate in this case to use a soft bottom. So let's go ahead and start selecting our entities. So the top surface is where the tool first hits material. Now let's recall something here. Since we've faced, we've already removed this amount of material, so it's actually the top of the part now where the tool first hits material. So that's what we want to pick as our top. So because of this, I'm going to temporarily hide my stock. So I'm going to go into the tree, expand my setup for my product for setup 1, right click on the stock and hide this temporarily. And I'm going to go ahead now and pick on the top here in the image and pick the top of the part. So again, this is where the tool first hits material. The next thing I'm going to select is the profile itself, or the wall that's going to be profiled. So I'm going to click on this. And notice that this Edge Selection dialog or menu bar appears. We talk about this in another video. For now, I'm just going to go ahead and pick a circuit of edges that goes around the entire boundary. Now, which edges to pick? One could pick this edge here, or one could pick this edge here. It doesn't really matter whether or not you're at the top or the bottom. Right now, you're just defining the circuit. So either one of these would work as long as it's a continuous, makes the continuous circuit. So let's use the top. I'm going to go around, and there are 8 edges here because there are four straight segments and 4 corners. So again, it takes a little bit of time to do this, and it's not too much of an issue here because we don't have that many edges, but you can get the idea that if you did have a lot of edges, you might find it taking quite a bit of time, and that's where some of these other tools here come into play, which we talk about in another video. So I've got one more edge to pick. There we go. So now we've completed the full circuit, and I can hit OK here or double click in the background to select that. So now I have selected the wall, the profile wall. The other term that you will hear for this is guide. So notice that on the video or on the graphics display, there's a tag called guide, which matches up with what's just been selected. We're using a soft bottom, but we still need to find where that is. So let's click on this plane, and I'm going to go ahead and click on this bottom surface here because I want the tool to descend past that. So now that's selected. And because I want the tool to descend past that, what I'm going to do is I'm going to do an offset on the bottom. So I'm going to double click on this, and I'm going to offset the bottom downwards. Let's say -50 thousandths. So in other words, I'm making sure that the cutter descends past this, the bottom of the cutter descends past this. If I didn't do that, and I did the second setup, one would find that one would have a flash band running around there. That's a little bit of unmachined material, which is always challenging to remove. So let's hit OK here. And as I mentioned previously, we don't need to define limits because this is a continuous profile that runs around the entire boundary. Okay, so that's our first tab, or really our second tab, where we define the geometry. The next thing we're going to do is move over to our tooling tab. And you've seen before that CATIA selects or keeps selected the tool that was used in the previous operation. Right now, CATIA is thinking that it's going to use this face mill to machine that profile. Probably not a good idea, so we do need to change that. And we have loaded in a bunch of tools that we can use. So in this case, we're going to use a end mill. So we have our end mills down here. We have a 1/2 inch end mill. That's carbide, a 1/2 inch end mill. That's high-speed steel, and a 3/8 end mill. We're actually going to use the 1/2 inch carbide end mill to do this. So again, to select a tool, we need to go over here to our select a tool in document, and we need to scroll down here through the list to our 1/2 inch carbide 3-fluted end mill. And notice that CATIA selects that tool and the image for that tool appears. Again, if you hold on the control button and the middle mouse button, you can scroll in and see all the dimensions, geometric dimensions of the cutting tool. Now, one of the things that you do have to do here is you have to change the tool number to match the tool load that's going to be set up on the machine. Your instructor will give you this information if you're doing this as part of an assignment, or you would need to find this out and decide upon your tool load prior to doing this. In this example, we're going to use tool number 2, so we're going to change the tool number from 32 to 2. But this is really important because that's what the code is going to have in it to tell the machine what tool to load to do this operation. None of our machines have 32 tools in it, so if you left 32 there and tried to run it, it would give you an error on the machine. So it's really important to get the tool number right. If you recall too, there's more information here beyond just the geometry of the tool. Clicking on the More button brings up, first of all, the same information here in text form that's on the image. But we also have technology information, so the number of flutes in the cutter, which way it rotates. In this case, it's a one-piece carbide-coated tool. And then, most importantly, the speeds and feeds. So these are the speeds and feeds that we've set based upon experience and the manufacturer's recommendations for this tool. And this is what is typically copied over into the process, which is the next tab. So again, these are the 3 tabs that have to be completed, and these are part of the information on the tool in the catalog. So you typically don't have to do this if you're using information tools from a catalog. So that's the 3rd tab, or the 2nd we've defined. Let's go over to the next one, and this is our information for the process on speeds and feeds. And what this does is it copies in the information from the tool. So we're machining at 120 inches per minute, and then we're finished. This is rough machining, and then we're finishing at 20 inches per minute. That's our feed rate. And with carbide, we're running this 1/2 inch end mill at 6,000 RPM. Also specified here are the approach speed and the retract speed. The approach is the speed at which the tool enters the material, and then the retract is the speed that the tool pulls away. 15 inches per minute is relatively slow. This would assume that the tool is coming in into the material from above. If you're using, depending on your lead in, lead out, this can be increased. I'm going to bump this up to 20 inches per minute because I'm anticipating that the tool is going to come in from off the part, from the side, rather than coming in from above. So we can always push the feed rate up when that's the case. Again, you can override the machining feed rate of the tool by deselecting, and then this becomes editable. The same thing is true for the spindle speed. You can deselect and then edit this. So in the next video, we're going to talk about the remaining 2 tabs, the one that sets the lead in, lead out, and the one that sets the machining strategy.